Good day everyone. I am Nicole B. Caitum and today I will be discussing about the log-normal distribution. So this presentation is composed of four main parts. First part is the introduction, which includes the definition of log-normal distribution. Second is the application and graph of the log-normal distribution. Third are the formulas that will be used in computing problems regarding log-normal distribution. And lastly, exercises, which includes 3 sample problems. Ano nga ba ang log-normal distribution? A log-normal or Galton distribution, another name for it, is a probability distribution with a normally distributed logarithm. Ibig sabihin, ang log-normal ay composed of normally distributed logarithm. A random variable is log-normally distributed if its logarithm is normally distributed. Masasabi nating ang random variable, may it be x, y, etc., ay log-normally distributed kung ang logarithm niya nga ay normally distributed. So sa next slide, hihimayin natin yung definition niya para mas maintindihan. If y is a normal random variable, then x equals e raised to y follows a log-normal distribution. So dito, nag-denote tayo ng random variable which is y, which is normally distributed. Ibig sabihin, x equals e raised to y ay log-normally distributed. The distribution receives its name from the transformation used, y equals ln of x. Yung name na log-normal ay mula sa transformation ng y equals ln of x. It is a right-skewed and takes values in the range of 0 to positive infinity. Ang graph ng log-normal ay right-skewed at mayroong range from 0 to positive infinity. Dito sa blackboard ay i-explain natin further kung ano nga ba ang log-normal distribution through equations. Assume that a variable y has a normal distribution with parameters mu and sigma squared. So ngayon, i-define natin ang relationship nitong y sa variable x. The relationship is that x would be equal to e raised to y. Itong exponent na y ay itong variable na y na normally distributed. Thus, we can say that x has a log-normal distribution. Ang reason kung bakit nga siya ay tinawag na log-normal distribution is because y equals ln of x has a normal distribution. Nagmula ito sa pagkuha ng natural logarithm ng equation ng x equals e raised to y. So, ln of x equals ln of e raised to y equals to y equals ln of x, kung saan ginamitan ng property ng logarithm na ln of e raised to u equals u. Next, the range of y is from negative infinity to positive infinity, and the range of x is from 0 to positive infinity. Again, makikita natin ito sa relationship ng x at y. So, habang papalapit ng papalapit ang value ng y sa negative infinity, ang value naman ng x ay papalapit ng papalapit sa 0. At pag ang y naman ay papalapit ng papalapit sa positive infinity, ganon din ang value ng x. So, ipakita natin ito dito sa ating calculator. Input tayo ng equation. I-try natin is negative 1. X is equal to 0.4 approximately. I-try natin is negative 2. Approximately 0.14. I-try natin is negative 5. Approximately 6.7 times 10 raised to negative 3 na ang value ng x. So, makikita natin na papalapit talaga siya ng papalapit sa 0. So, itry natin is negative 999. So, nag-0 na talaga ang value ng x. I-try naman natin is positive. Positive 1. Approximately 2.72 ang value ng x. Positive 2. Approximately 7.39 ang value ng x. Try natin is positive 5. Approximately 148.41 na ang value ng x. So makikita natin na papalapit talaga siya ng papalapit sa positive infinity. So makikita natin yung laki ng difference from exponent na 2 to exponent na 5. So, we can say that x has a log-normal distribution with parameters mu and sigma squared. Dito dapat maging careful tayo. Ang parameters na ito ay hindi parameters ng x. Ito ay parameters ng variable y. These parameters are the expectation and variance of the variable y. Application of log-normal distribution. So, saan nga ba nagagamit ang log-normal distribution? It is very commonly used to describe lifetime distributions such as lifetime of products, components, and systems. The following phenomenon can all be modeled with a log-normal distribution. So, dito, madalas nagagamit ang log-normal distribution or pwede dito magamit. Milk productions by cow, lives of industrial units with failure modes that are characterized by fatigue stress, amounts of rainfall, size distributions of rainfall droplets, the volume of gas in a petroleum reserve. Many more phenomenon can be modeled with the log-normal distribution, such as the length of latent periods of infectious disease or species abundance. So these are the graphs of the normal and log-normal distribution. So dahil natakal na ang normal distribution ng past reporter, meron na tayong idea kung ano nga ba ito. The blue one is the normal and the orange one is the log-normal. Ang graph ng log-normal ay right-skewed. Makikita natin ito dito. Pwede rin itong tawaging positive skew because as you can see, it has a long right tail. So, andito yung long right tail niya, makikita naman natin. Compared to the normal which is a bell curve and is symmetrical. So, yan lang naman yung difference ng graph ng log-normal at ng normal distribution. So, ang pinaka dapat tandaan is sa log-normal is right-skewed or pwede siyang tawagin na positive skew. At ang dahilan nun is because meron siyang mahabang right tail. Since ang log-normal nga ay normally distributed ang logarithm, pwedeng ma-transform ang isang normal distribution into log-normal and vice versa. So, if we have a variable y normally distributed with parameters mu and sigma squared, and if we operate the variable x, then we can say that x equals e raised to y is log-normally distributed with parameters mu and sigma squared. We can move in the opposite direction. If x is log-normally distributed with parameters mu and sigma squared, then we can say that y equals ln of x is normally distributed with parameters mu and sigma squared. So, knowing the facts, we now know that the probabilities of a log-normal variable are obtained by transforming a normal variable. Because of this, we can obtain the cumulative distribution of log-normal using the cumulative distribution of a standard normal variable z as follows. F of x equals probability of variable x is less than or equal x equals the probability of e raised to y is less than or equal to x equals the probability of y is less than or equal to ln of x equals the probability of z is less than or equal to ln of x minus mu all over sigma. Ang mga formula pa na ito ay ating gagamitin sa pag-solve ng problems. Probability density function, expectation, and variance. Probability density function or PDF is f of x is equal to quantity 1 over the product of x sigma and square root of 2 pi multiplied by exponential of negative the square of the quantity ln of x minus mu all over 2 sigma squared, given the condition that x is greater than 0 but less than positive infinity, and f of x is also equal to 0 elsewhere. So dun sa past slides, nalaman natin na ang x log normally distributed with parameters mu and sigma squared ay parameters ng variable y na normally distributed. So, paano nga ba natin makukuha ang expectation and variance ng variable x? So, expectation of x is equal to exponential of mu plus sigma squared over 2. And variance is equal to exponential of 2 mu plus sigma squared multiplied by the exponential of sigma squared minus 1. Sa next slides, magsa-start na tayong mag-solve ng sample problems related sa Lognormal distribution. Example problem number 1. The Department of Energy has a chronic beryllium disease prevention program. The focus of this program is to monitor equipment and buildings for beryllium contamination and exposure of workers to beryllium in the workplace. Data given in Table 6.3 were collected from a smelter facility used to recycle metal where beryllium contaminants tend to deposit on all surfaces. Wipe samples were taken randomly from surface equipment in the workplace and tested for possible beryllium contamination, measured in microgram per 100 centimeters squared. The distribution of data shows that log-normal distribution is reasonable choice to describe beryllium contamination at this smelter. From the samples, the estimated mean to be negative 2.291 and standard deviation to be 1.276. Meron tatlong hinahanap sa ating problem. Letter A or first is, if a wiped sample is taken randomly from this smelter, what is the probability that it will have beryllium contamination exceeding 0.50 microgram per 100 centimeters squared? Letter B is, the DOE has established a safe limit for beryllium contamination to be L subscript 0.95 is equal to 0.20 microgram per 100 centimeters squared, where L subscript 0.95 indicates 95th percentile. Use this data to determine the safety of workers' health and smelter. And last is the expected amount of beryllium and the variance. For letter A, let x be the beryllium contamination, then ln of x follows a normal distribution, with mean negative 2.291 and standard deviation 1.276. Therefore, using the above stated result and standard normal cumulative distribution function, we get the probability of x greater than 0.50 is equal to 1 minus the probability of x is less than or equal 0.50. Then getting the normal logarithm of the probability, 1 minus the probability of ln of x is less than or equal ln of 0.50. So, kinuha lang natin yung natural logarithm nito. Kaya naging ln of x as ito is naging ln of 0.50. Then, 1 minus the probability of variable z less than or equal the quantity ln of 0.50 minus negative 2.291 divided by 1.276. Itong formula na ito is na-discuss na doon sa past slide. Ito yung cumulative distribution function. So, isa-substitute na lang natin itong mga given para mahanap natin yung sagot. So, itry natin ito sa ating calculator. ln of 0.50 minus negative 2.291 divided by 1.276. Ang sagot is approximately 1.25. So, 1 minus the probability of variable z less than or equal 1.25. So, itong 1.25 ay hahanapin natin sa ating z-table or z-score. So, 1 minus 0.89. So, yan yung galing sa z-score. So, dahil na-discuss na ito ng past reporter, may idea na tayo kung paano gamitin yung table. Pero balikan na lang rin natin para mas alam natin. So, yung whole number, kasama na yung first decimal or yung first decimal is titingnan natin dito sa left side. Tapos yung second decimal is titingnan natin dito sa taas. So, 1.25 yung nakuha nating sagot. So, hanapin natin 1.2. Dito siya. Tapos, yung next na decimal is 0.05. So, susugsugin natin siya dito sa table. So, ang sagot niya is 0.89435 or approximately 0.89. So, yun yung nilagay natin dito. So, isolve natin siya. 1 minus 0.89 equals, ang sagot is 0.11. So, ang probability na ang x ay greater than 0.50 ay 0.11. Yan ang ating final answer for letter A. For letter B, we need to determine L subscript 0.95 value for this melter such that probability of x less than or equal L subscript 0.95 is equal to 0.95. Therefore, from the above result relating to normal and log-normal distribution, we get the probability of x less than or equal L subscript 0.95 is equal to the probability of variable z less than or equal to the quantity ln of L subscript 0.95 minus negative 2.291 divided by 1.276 is equal to 0.95. Using cumulative distribution function, we get ln of L subscript 0.95 minus negative 2.291 divided by 1276 is equal to 1.645. So, yung 1.645 ay nakuha natin sa z-score percentile for normal distribution. So, dahil nga ang given is 95th percentile or 0.95, hahanapin lang natin siya sa z-score. Nakakahanap naman ito sa internet. So, dito siya, ito yung nahanap ko. And i-zoom in lang natin. So, ito, 95 is 1.645. 95th percentile is 1.645. So, isa-solve natin yung nag-up tayo na equation. So, cross-multiply natin yun. We will get ln of L subscript 0.95 minus negative 2.291 is equal to 1.645 times 1.276. So, i-transpose lang natin to sa kabila. We will get ln of L subscript 0.95 equal to negative 2.291 plus 1.645 times 1.276. So, kunin natin yung exponential both sides. Exponential of ln of L subscript 0.95 is equal to exponential of negative 2.291 plus 1.645 times 1.276. So, magiging na siyang L subscript 0.95 is equal to exponential of negative 2.291 plus 1.645 times 1.276. So, itry natin siya sa ating calculator. O, ito. E raised to negative 2.291 plus 1.645 multiplied by 1.276 equal to approximately 0.825. So, yun yung nakuha natin sagot. Ang nakuha nating sagot ay approximately 0.825. And 0.825 is greater than 0.20. Because this estimate of 95th percentile exceeds the DOE safety limit of 0.2, we can conclude that the beryllium contamination at the smelter is at an unhealthy level for workers. So, dahil nag-exceed siya dun sa binigay ng DOE, unhealthy siya para sa mga worker. So, ito yung ating final answer. So, for letter C, the expected amount and variance can be calculated as follows. Expected amount. So, gagamitin lang natin yung formula equals exponential of mu plus sigma squared over 2. So, substitute natin yung given. Exponential of negative 2.291 plus 1.276 squared over 2. So, itry natin sa ating calculator. E raised to negative 2.291 plus 1.276 squared over 2. So, ang ating sagot ay approximately 0.2283. So, ang ating nakuhang sagot ay approximately 0.2283. So, yan yung final answer for expected amount. So, for variance naman, gagamitin lang din natin yung formula for variance equals exponential of 2 mu plus sigma squared multiplied by exponential of sigma squared minus 1. So, isubstitute natin yung given. Exponential of 2 times negative 2.291 plus 1.276 squared times exponential of 1.276 squared minus 1. So, itry natin ulit siya sa ating calculator. So, unahin na muna natin itong exponential na ito para hindi tayo mahirapan. E raised to 2 times negative 2.291 plus 1.276 squared equals to, i-stack muna natin siya dito sa A. Shift stack A para ma-save siya. So, gawin naman natin is itong kabila. Alpha E raised to 1.276 squared minus 1 equals, okay, i-stack naman natin siya sa B. Shift stack B. Okay. So, ipag-multiply na natin sila. So, para hindi mahirap. Alpha A times alpha B is is equal to approximately 0.0977. So, ito yung nakuha nating sagot. Ang sagot is approximately 0.0977. So, ito ang ating final answer for variance. Example problem number 2. Concentration of pollutants produced by chemical plants historically are known to exhibit behavior that resembles a log-normal distribution. This is important when one considers issues regarding compliance with government regulations. Suppose it is assumed that the concentration of a certain pollutant in parts per million has a log-normal distribution with parameters mean equals 3.2 and standard deviation equals 1. What is the probability that the concentration exceeds 8 parts per million? Solution. The probability of x is greater than 8 equals 1 minus the probability of x is less than or equal 8 equals 1 minus the probability of ln of x is less than or equal ln of 8. So, kinuha lang natin yung natural logarithm nito. Gamit lang yung cumulative distribution function. Isa-substitute natin yung given. 1 minus the probability of variable z is less than or equal ln of 8 minus 3.2 over 1. So, itry natin siya sa ating calculator. Okay. ln of 8 minus 3.2 over 1. So, ang sagot is approximately negative 1.12. So, 1 minus the probability of variable z is less than or equal negative 1.12. So, ito again is hahanapin natin sa ating z-score o dun sa table. So, ito yung table. So, ang whole number is negative 1 and yung first decimal is 0.1. So, hanapin siya. Nandito siya, negative 1.1. And since negative 1.12 yung nakuha natin, yung second decimal niya is 0.02. So, sugsugin natin ulit dito, tapos ito. So, siya ay 0.1314. So, 1 minus 0.1314. So, itry natin sa calcu. 1 minus 0.1314. So, ang sagot ay 0.8686. So, ito na yung ating final answer. Example problem number 3. Suppose that the reaction time in seconds of a person can be modeled by a log-normal distribution with parameter values mean equals negative 0.35 and standard deviation equals 0.2. Find the probability that the reaction time is less than 0.6 second. Solution. The probability of x is less than 0.6. So, kunin natin yung natural logarithm equals the probability of ln of x is less than ln of 0.6. So, equal the probability of variable z is less than ln of 0.6 minus negative 0.35 over 0.2. So, sinubstitute lang natin yung mga given. So, itry natin ito sa ating calculator. ln of 0.6 minus negative 0.35 over 0.2 equals, so ang answer is approximately negative 0.80. So, the probability of variable z is less than 0.80. So, hahanapin natin siya ulit sa z-score or dun sa table. So, ang unang decimal is 0.8. Negative 0.8. So, andito. Tapos, since 80, so 0. Yung second, andito siya. Sugsugin natin ulit. So, siya ay 0.2119. So, the probability is 0.2119. Ito yung ating final answer. Thank you for watching and listening. So, kung may further questions kayo, pwede nyo akong i-message through Facebook Messenger. Tapos, sa email, nicolebangcaitum@gmail.com.